Hey guys, in this video I will be showing you how to evaluate a limit using the graphical approach through a few examples. The first example here asks us to determine the limit when x approaches 0.5. As we can see on the graph, when x approaches 0.5, we can see that the graph approaches 1.5 from the left side and 1.5 on the right side. This side would be called the left-sided limit, and this side would be called the right-sided limit. In this case, the left and the right-sided limit approach to the same value. The limit here at x is equal to 0.5 would be 1.5. And this is how we would write up the answer. A similar example asks us to determine the limit of x approaches 0.5 of g of x. On this graph, we can see that this graph is not continuous. In fact, there is a jump discontinuity. There is a hole in the actual line and a point somewhere else. However, we can see that as x approaches 0.5, the left side still approaches 1.5 and the right hand still approaches 1.5, even when there is a hole at that point. In our next example, we are supposed to find the one-sided limits at x is equal to 1, 2, and 4. As x approaches 1, we can see that the left side approaches 3, while the right side approaches 1. And these would be the notation for left-sided and right-sided limits. For left-sided limits, you would put a negative side next to the number on the bottom, and for right-sided limits, we would put a positive sign after the number beneath the limit. When x approaches 2 from the left side, we get a limit of 2, but from the right side, the limit approaches 1. So here we would write it as x approaches 2 from the left side, the limit of f of x is equal to 2, and when x approaches 2 from the right side, the limit of f of x is equal to 1. As x approaches 4, both the left-sided limit and the right-sided limit approach 2. And since both the left and the right-sided limit equals the same value, we can just write as x approaches 4, the limit of f of x is equal to 2. This example asks us to determine the one-sided limits as x approaches 2 and 4. On this graph, we can see that as x approaches 2, the left-sided limit approaches positive infinity, and the right-sided limit also approaches positive infinity. Therefore, we would write it as x approaches 2, the limit of f of x is equal to positive infinity. As x approaches 4, the left-sided limit approaches negative infinity, and from the right side, the limit approaches 10. So we would write it as x approaches 4 from the left side, the limit of f of x is equal to negative infinity. And as x approaches 4 from the right side, the limit of f of x is equal to 10. This example asks us to determine the infinite one- and two-sided limits. As we can see from this graph, we can see that there will be a left-sided limit for -1, a right-sided limit at -1, a left-sided and right-sided limit for 3, but will equal the same value, and a left-sided and a right-sided value for 5, and they will also equal the same value. As x approaches -1 from the left-handed side, the limit approaches -infinity. And from the right side, the limit would be positive infinity. As x approaches 3 from both the left side and the right side, the limit approaches positive infinity. And as x approaches 5, the left-sided limit and the right-sided limit both equal to -infinity. And that summarizes how to evaluate a limit of a function using the graphical approach. We have looked at left and right-sided limits, continuous and discontinuous functions, limits which are positive and negative infinity, and that's it.